40 minutes, but I think I have so many slides that you have to listen to me at least 40 minutes if you want to see the last slide. Anyway, let's get started. So today we will talk about winter maintenance practices and special life cycle cost of paved road. And talking about ROADEX in general, winter maintenance has not been so much like a research or information sharing issue on ROADEX since, but in ROADEX 1 from 1998 to 2001, ROADEX winter maintenance was also part of the topics on at that time, and there are actually 2 reports published on the ROADEX website. It is a wind maintenance practice in Northern Periphery, and then summary report and conclusion, which is pretty much the same, slightly different issues, and then quite interesting results also from Norway, generation of snow smoke behind heavy vehicles. And both of these you can still find these reports on the ROADEX website. Why we didn't continue too much on winter maintenance later on, the reason was that it was pretty much on climatic conditions. So we found out on this first ROADEX project that the winter maintenance environmental issues, how do you plan winter maintenance, was so different in Finland and Sweden compared then to partly Norway and especially Scotland and later on Iceland and Ireland. So that is why it was left off. But since later on we started to go through very much on the life cycle cost and ROADEX started to focus on also on benefit and savings and achieving more with less. And this is there's one report published I think in 2012 or 13 about these issues. And in general, talking about very much on budget cuts, for instance, here in Finland, really big political issues with the funding of government need to cut funding almost every area, and sooner or later it probably hit also the road maintenance. Anyway, in early ROADEX project, we did research also that how organization in general react over there, and there was like three issues, like accept the situation and don't change practices and just blame politicians, the classic ones in many countries. Then adopt new technology, improve practices, so improve also productivity, and then you can do more with the slightly less resources. And finally, the 3.1 was the impact vehicles that are damaging the roadway, because that's heavy vehicles are the main issue, especially on low volume roads. We have done that especially on the forest road, not so much on gravel road, and especially not so much on paved road, but that's also an issue. But this number 2 is what we've been mainly working over there. Talking about winter maintenance, because it is so much, it's very closely related to the drainage. Here's just one example of a winter drainage project that we did in 2009, 2011, 2012. This report, but it was a longer report on around Rovaniemi area, and for me this is a nice example that about what is reactive maintenance and what is proactive maintenance. So there was a there was a frost bump in this private access road junction, and then GPR shows and the data shows that they made a soil replacement because of this bump in 2009. But then in 2010 and 11, when we were monitoring these roads, so you can see that the rutting IRI was lower. It was only 5, but still rutting was more than 20 millimeter, even though it was fixed earlier. And so basically, instead of doing relatively expensive soil replacement, you should be going and fixing the culvert and drainage system on this private access road junction. Would be thousands and thousands of cheaper solutions. So fixing the root cause instead of being reactive with the symptoms, it always pays back. Anyway, one title of this presentation is about this life cycle cost in general, and question is that in road maintenance management, it's not so much like it's quite much discussed, but very seldom really calculated in a scientific way. So why we need that? Of course, the main basic issue in asset management is that it's a road is not one-time expense, but it's a long-term asset, and the benefit is, first of all, that we minimize the total cost, so we can choose the best fit maintenance strategies, and that cost least or less over the lifetime. Then we can do, so to say, correct measurement in correct places and correct time. So treatment at the right time, also preventative maintenance is the other issue, which is quite like using de-ice, preventative de-icing salt is a nice example of preventative maintenance also. Support decision, prioritization, knowing that we have limited budget, but once we have limited budget, we should be able to compare alternatives and prioritize based on these comparisons. Then drive comfort, user cost. We know that fuel costs are increasing about 15% if IRI goes from 201 to 4. But for the latest information tells that for instance, once we now have electric cars with a lot of electric components, so when IRI starts to go higher than 4 or 5, the mechanical problems related to electronics start to increase, exponentially increase on that issue, and that's one future problems and motivation to keep roads smooth. And of course, environmental issues, sustainable, durable infrastructure. So that is also one issue where we can what we should always keep in mind. So the information that I'm sharing now is basically, or most of that information is coming from the Pehko project that started in 2015 in here in Rovaniemi or northern Finland and central Finland, and then in 2018 it was expanded to Hyvinkää area, so very close to Helsinki, our capital area, with the very high traffic volume roads and slightly different type of network. Also, the environment is different. But the ambitious goal was in 2015 was that in 2025 we should have annual paving cost 50% lower than in 2015 levels. At the moment we are in 2026. We know now that we didn't manage that. We managed to do savings about 30 to 40%, but if we had resources to hit and focus on all this expensive sections, so according to the calculation, then we would have been able to hit this 50% target, but very close anyway. We came that. So in general, what we plan to do is there was a three goals. First of all, road maintenance standards, especially drainage maintenance. At that time, we didn't know how much winter maintenance is also how important is that. We calculated that based on the ROADEX, we calculated that it was 10 to 30%. Then new technologies, focusing on the weakest sections, this, so to say, targeted rehabilitation savings 10 to 40%. We had evidence on that. Also, we have partly done that, but not so much on Pehko. And proactive maintenance. That has been also been introduced with a very promising results, but this is a very long-term change, and this process is still continuing. Anyway, don't have too much time to go to the data collection and analysis technologies and everything else, but in general, we surveyed all the roads, all the lanes in these areas with the road doctor survey one, with the GPR LiDARs and the videos and accelerometers, so get the structural and surface condition. That was every year, and then with the Greenwood TSD, or actually Polish TSD, but Greenwood, made by Greenwood, we surveyed also every 5 years. So we have now from Lapland and central Finland 3 measurements 5 years apart. And then what we've been doing, analyzing all this data, bringing them partly to the point cloud to show, like in these photos, very nice connection, that what happens if your outer slope is unstable and starts to fill the ditches, and now where the water, let me see here. Just put a laser pointer. So water in the ditches flows and then meets these filled places, so it goes under the road structure, and here you see moisture under the pavement structure, and then saturates the road shoulder and causes the deformation. So a nice example how important this is to have and how important is also to clear the ditches. When calculating the life cycle cost, one surprise for us was also on these areas that life cycle cost in general, we thought that it's more very close to, or much more a function of traffic volume and at different classes. And here are these Lapland, Uusimaa, and central Finland areas, and blue bars are percentage of roads in each classes, and red bars are the annual paving cost that we have been measured. We thought that in low volume road, these red bars are much, according if it was a function of traffic volume, we thought that it should be much lower lower, and then when you go higher volume roads, they should be much higher than blue bars, but it was surprisingly small differences. And what you can see also, that when you are talking about the amount of these roads, so in central Finland, 80%. From Uusimaa, which is probably the most urban area, so almost 40%, and then Lapland 60%. But most of the roads are still the roads in Finland where our AADT is less than 2,000. Also, then other issues on the life cycle cost is that how these costs are distributed at different classes. Here is a comparison on the of all these areas, central Finland, Lapland, and Uusimaa areas, and green bars are where the life cycle costs are less than 1.2 euros per meter per year, and black ones are where it's 10 times higher. And in general, what we should see, for instance, this black 10 times higher, or red ones are 6 meters, so it's about five times higher, is that we should see them only on the high volume road, but surprisingly high amount of black and red that are causing the payment backlog can be seen also on the low volume road, which explains the difference between this red and blue bars in the previous windows. So the heterogeneity of this road was a challenge. Then in general, what we did also, and what the idea was that and what has been talked many years in Finland, that the biggest problem is studded rutting due to the studded tires. But our results were quite surprising that actually the studded tires in general started to be like the dominant factor only after AADT 6000. Then basically it just like a tire wear is you have to think about that. And I think the reason for that is the ASTO project and in Finland and the two roads about 20-30 years ago, 40 years ago, when Finland did quite much research on the aggregate and in asphalt against wear to the studded tires, and we ended up a very good design and specification for studied. And at this time, what we can see, like in these photos, that the only sections where we see very big wear to the studded tires is where the cars are braking or accelerating, like intersections. There you can see this wear, like in this photo. And in general, if you are talking about studded tires, in Finland, it's under this blue bar, this nastarenkaat means studded tires. So what we can, if we calculate a rutting per 100,000 vehicle, what we can see in general that maybe the proportion of studded tires is something 0.040 millimeter per 100,000 vehicle, and even in the high volume roads, this is only, it is about 40 to 50%. But over there you can see also deformation, other type of deformation. But basically everything which is above in this horizontal red line, it is deformation or some other related problems, mode 1 rutting or mode 2 ruttings. Then in general, we don't go too much on the structural issues, but here's the summary of Pehko project that I have been many times showing already. So we found basically 7 reasons for paving backlog in Finland. Heavy trucks, weak upgrade, heavy trucks, too thin pavement quality in certain areas. They are like the pavement design problems. Then drainage problem, private access road problems, drainage problems, side ditches, winter drainage problems, especially delayed removal of snow walls, and then extensive use of de-icing salt and especially in thin pavements. And later on, what we could say that the 8th problem is probably insufficient funding and too reactive maintenance policies. But now we will focus very much on winter maintenance issues. And if we want to list these winter maintenance issues, critical issues that are affecting the life cycle cost on maintenance, we can find at least nine things that you use in a way checklist that you have to recognize and keep in mind. First of all, lowering snow walls in time, then preventative removal of snow walls. Lowering snow walls means that you are lowering them to the 20 centimeter level, and then preventative removal is that you are taking the rest of the snow walls also away, and that should be done before the snow starts to melt. Then private access road junction, and especially with missing or frozen culvert, bus stops, rest and rest areas, no storage. Then motorway center areas is one thing I don't have time to talk to today, but keeping the snow away from there. From that we have very good experience also from Central Europe, how important is that. Missing transverse crack sealing affects also. Then transverse cracks, tenting issue with the transverse crack and high usage of salt. Then increased usage of de-icing salt and thin pavement, and then slush ice in formation of ditches. The slush ice was a big problem in 2012 to 14, but when ROADEX started, for some reason we haven't had too much problem since that. Anyway, talking about winter maintenance, here is the in one photos 2 biggest problems. So private access missing or totally frozen private access road junctions, and then delayed removal of snow, and now we will first focus over there. So first of all, delayed removal of snow. If you see wet surface, this is from 2015, these photos, and when we started it, you could see even in February, and especially then March and early April, you could see these kind of photos where the water was lying on the pavement, and then in late April on this section where the water was lying, you could see, even though it hasn't been raining for days and days, you could still see water pushing through the pavement to the road surface, which is a clear indication of really big weakness on the pavement. Also, in 2015, what was it was quite much discussed about problems in the roads during the springtime, and what was very interesting at that time that that I collected some news at that time, Finnish TV news, and all the photos from the really bad potholes were from the sections where there were guardrails. And you could see on the roads also, potholes were developing. Guardrails and behind the guardrail there were high snow walls and they were wet. So most of them. What we did also research on that and some reason why this happens is that here's a like graphic explanation what is happening. So in the winter time, when it's cold and you are leaving the snow walls like in January, snow walls over there, it's minus degrees, and but then when the first warm days come, like it has been now last 2 days in Finland where it's +5. So now you have the deeper structures -4 degrees, snow is melting and starting to fill the pavement. But under the pavement, the temperature goes between 0 and -5, which is the area where cross-action, so very high negative pore water pressure, is starting to absorb water from this. So it is really sucking the water under the pavement, and then comes next freezing days. Like it will be still coming here, -10 degrees. It goes again below -1 degree, and that means that you start to develop ice lenses, which is called, like in Luleå Technical University, has been calling them tertiary ice lenses that pushing road shoulder up, and then it saturates the pavement, and finally it starts to melt. When this material starts to melt, you have a very high deformation in the road shoulders. And this also can be seen on Aurora Research, this autonomous ITS Aurora Research Center, where we, with Tampere University, had instrumented sections. And on 0.32 centimeter on the base course under the pavement, what you can see just on the section where the air temperature, this blue one, starts to be positive and started to melt the snow. So this is 2018 and there's 2019. So water goes under the pavement, and for instance, in this case, even in 32 centimeter deep, the displacement is about 6 to 7 millimeter. In 2018, it was only it was only about 4 to 5 millimeters. But anyway, it is quite big one, and means that there are ice lenses just under the pavement. What can be done and what should be done according to the specification and what was started on Pehko project was that we started to use lowering the snow walls to 20 centimeter. Why it was not totally removed? Because people were afraid that because drivers have been used to have snow walls to know where's the road, so you had to have some kind of snow wall. But we followed the Swedish practices to lower the snow walls and also remove the snow behind the guardrails. And according to the test, it was a really great impact on these sections. Only issues were in some areas that, for instance, that reflection bowls, like here, not everybody had machinery to remove snow behind the reflection balls, and they were left, and then what you could start to see that that even such a small amount of snow could saturate things that you could see a deformation, edge deformation. And here's a point cloud routing map and showing the also the reflection pole exactly on the section. So even this amount of snow could cause so much frost heave and deformation that you have problems in the road shoulder. So this, in general, this was okay. Anyway, the problem in general was that especially the total removal of snow wall was in some springs, it was started not until it was very warm weather and climate started, or snow started to melt. And at that time, it is pretty much too late. And remembering also that if you start to remove snow wall only after you see roads like this, and the removal takes with the one contractor roughly 1 to 2 weeks, you are working too late. So it should be preventative, and according to the ROADEX recommendation, it should be like statistically done before normally the snow starts to melt. Here's an example from Lapland, in southern Lapland area, where it was especially in 2018, 2019, it was delayed. And here's the rutting development, relatively new road sections, and what you can see, really big jump on that area. But the biggest problem was in central Finland in winter 2019-2020, where we had about 5 times it was snowing, and then came so warm weather that all the snow was melting, and it saturated so much the road section that compared with the next year 2020-2021, once here you can see a rutting about 2 to 3 millimeter per road, when it's normally less than 0.5 millimeter. And what you could see when you calculate the cost, deformation, rutting cost, life cycle cost on these years, so it was 1.12 million on this test section area, when it was previous year 0.6 million, which is almost 2 times higher cost because of this issue. So we are talking in big money. And here's the calculation made by Tomi Heronen a couple of years ago from Uusimaa, Helsinki areas, and this was 2000. Prices are 2015 level, but calculated average cost on over there roughly 1.9 million if it was there, and if rutting increases this 50% as it was done in central Finland, it would be about 2.8 million. And once lowering snow banks and slush ditches, or removing the snow walls, it was about 120,000 in difficult winter, and only 50 if it's an easier winter. So we are talking about 22,000 for 120,000 euro cost. But if we don't do that, or if we do it too late, so cost, we are talking about 0.8 million, so almost at least 6 times higher cost. And if we are scaling this to national level, we are talking about First of all, annual cost effect, we can calculate about 13 to 17%. And if it's totally neglected or using, we are talking about tens of millions of euros. So timing on that is really big issue. And it is traffic safety issue. Here's a nice photo of Oulu area from 2019. So 2018 in Oulu area, it was still like lowering snow banks and removing snow was not practice, and almost exactly on the same time. Here are two photos of 2018 and 2019, and how what you can see how big difference is on the roads also. So it is definitely a traffic safety issue also. Then the other issue, what was really big surprise on Pehko was and a single maintenance problem was can be related to the drainage of and these private access road junctions during the spring. Here are also a couple of frost heave photos of these point cloud photos. You can see it means that if you see red ones, so you are around 100 millimeter frost heave, and if it's blue, so there's hardly any frost heave. But this is what we have been finding, and in ROADEX test sections, there were even more than 50% of all the pavement damages could be related to the access road junction. That was really big ones. Frozen culverts or missing culverts. And why the cost, even though access road junctions are normally about 10 to 20 meter wide, but once you are measuring the impact on this access road, it is roughly 100 meter. And here's just one example of this kind of problem in that frozen culvert. When in this time in this road, it should be less than 0.8 millimeter per year, and in this case it was more than 4 millimeter per year. And so it's roughly 150 meter around culvert. You can see this saturation. And then private access road culverts in central Finland is just showing the problems at the time when we started this work. So if in the left hand, what you can see is that how many percent was that culvert was missing or couldn't be detected. So we couldn't find. So it was a 60%. And when we were adding on the private access road also that culverts was not working, so it was 80%. So basically only 20% of the access road culvert was working as it was supposed to be. And then what we did also, I started to rank them. So we started that, okay, what is the worst private access road culvert and what is the rut increase, and ranking them. And this ranking showed that if you take the number 100 worst culvert, so over there we had still 7 millimeter per year, so only 3-year lifetime. And once we went to 500 worst culvert, it was still 3.5 millimeters. So it's average value, when average value was much less than 1.5 millimeter per year. And in central Finland, it was about more than 20%. I think roughly it was 12% of the paving budget was only. And if we are talking about life cycle cost on Finland, it was 20 to 4 million, But if you are talking about how much fixing this private access road culvert, it would be only 40 to 60 million. So basically, within 2 years, you will, if you start to work on life cycle private access road, you get your money back and basically start to mean. So payback time is extremely short. Then other issues is also like de-icing salt, thin pavement. In Finland on the main roads, it was increased the usage of salt. And interesting finding, which was, by the way, exactly the same as experiences from Canada, that if you start to heavily increase the usage of de-icing salt, you will have a few years on high rutting and pavement distresses. And here is a comparison of pavement thickness and annual rut increase after the increase of de-icing salt, and we could see exactly the same issue here. So this experience is from Canada. The good news anyway is that this takes place 1 year or 2 years, but in our cases in Finland also, after on the year 3 you couldn't find any more these problems. Crack sealing, transverse cracks. If you don't seal transverse crack, first you start to see problems in the winter time, like here in 2018, and then in 2020 you start to see already severe problems. So crack, especially transverse crack sealing, is a one issue what should be kept in mind, that it is causing bumps. Special problems that we encountered already in ROADEX drainage project was snow storage at bus stop and rest area. Here's an example of photos taken by weather camera stations in central Finland, where you see storage, snow storage on the bus stop here, and later in the spring you start to see damaged pavement. These kind of cases we see everywhere. Also in rest areas, this is from the northern Finland, and here is a rest area where the snow was also stored at the end of rest area, and severe frost bumps. For instance, in this section, the only severe frost bumps were at the end of rest areas we could find. So it's a really big impact. If you store snow, so you should make sure, and road maintenance make sure that they don't store the snow here, because all the melting snow goes under the road and causes frost bump. Then private access road junctions. So it's not only deformation, but it's also frost bumps. And here's the RDMC technique that we've been monitoring them. Here you can see on the private access road more than 200 millimeter frost heave. And here's the aerial photo of frost bump. And for instance, in this section in Lapland, about 60% of all the frost bump could be related to the private access road junctions. And here's just one example of a section from Rovaniemi towards Kittilä area, calculated a couple of years ago. What is the main reason? We calculated in the springtime all the frost bumps where IRA was higher than 6, and what was the main reason? And this is the section of access road junctions. Private access road about 1/3, filled ditches also 30%, and they were very much related to these access road junctions. Then standing up or water in the ditches, bus stops 10%, and 10% was also culverts with the missing main road culverts, but much less than this access road. So at the end of what are the potential savings on the daily maintenance? What if you put all these things together? We are calculating that, and here's the rough estimates, but we are talking about 30 to 50% savings. So at the moment in Finland, if we calculate annual saving cost, it's about 300 million euro per year. So we are talking about 100 to 150 million euro per year savings. And good news with this is that you could start that immediately. You don't need so huge investment on the daily maintenance. Once, if we are talking about structural problems, thicker payments, its impact is roughly 30 to 35%, but every 50 millimeter in the whole road network in Finland cost about 2 billion euro. So it takes tens of years. It's a long project. Roads on Paved, it's not so big one, and we roughly evaluated maybe 100 to 200 million euro. Proactive maintenance, we should start that, and the material and structures about 10 to 50%. But this is a very long terms. But daily maintenance, winter maintenance, you could see immediately the impact. So finally, conclusions and lessons of the learns. What we've been learning is that in pavement design and programming, the return of capital is in a long term. We need to know that. So we have to have life cycle cost analysis. And in general, thicker payments, so this is a structural issues, and much shorter sections than we have been doing before. We have to improve our structures. But then also root cause of the problem always should be fixed, and especially these drainage and winter maintenance issues. Problematic drainage sections should be improved and make sure that they stay there. And then private access road junctions, especially surprisingly big problem over there. And what I have been seen in the neighboring countries also exactly the same problem. And then finally this winter maintenance and removal of snow in road shoulder early enough, rather too early than too late. And here's just example of this impact of this life cycle analysis, that there are some models and experience on that. So for instance, the road network in Finland is getting older and older. So we are now routine maintenance and partly rehabilitation need. So if we are talking about cost analysis, so it's really huge difference when we start to use life cycle cost analysis on this time, and it's extremely beneficial. So that's about winter maintenance this time. So thank you. Is there any questions?